Let's look at question 5. I have a graph paper here, but the question now it says Z is 6 minus J3. You must plot the Argand diagram. Alright, first of all, the 6 minus J3. How would it look just before we put it on the graph? If this is 0, as the X and Y axis, you go out 1, 2, 3, 4, 5, 6 out here. And J3 minus, so you go down 1, 2, 3. Both of them would intersect right here. So from the origin, we draw the line this way. So that would represent the Argand diagram. It would look something like this. But anyway, let's use the graph paper. 6 minus J3. We could have our x-axis here. Let's put our y-axis here. If we say 6, you're going, if 1 centimeter equals 1 unit, you go 1, 2, 3, 4, 5, 6. But could we go more? Let's do a 2 centimeters equal 1 unit on the x-axis. You go 1, 2, 3, 4, 5. Alright, it means I want this y-axis to be here. So here this is 0. I have 1, 2, 3, 4, 5, 6. And on the x-axis, -1, -2, -3. Alright, good. But I could move the x-axis up a bit more to, let me move the x-axis further up. Okay, so now I have 0, 1, 2, 3, 4, 5, 6, -1, -2, -3. So both of them would intersect here. So the Argand diagram do something like this, right? You would here have this line as J3 and this out here as your 6, all right? Now you're going to have an angle here, which we call the argument, and then the length of this line we call the modulus. But anyway, let's look what the question says. Plot the Argand diagram. Okay, calculate the modulus. Now remember, this is 6 long, right? See that? And this is 3 long. 3 would come this way. But I remove those dimension lines just not to overcrowd the diagram too much. But the modulus, call it R. We can calculate it using Pythagoras theorem because this is a right angle triangle, right? So you have R squared equals 6 squared plus 3 squared. Now R squared would be 36 plus 9, which is what? 36 and 9 is 45. So R would be the square root of 45. Let's use a calculator to find out what the square root of 45 is as a number. Square root of 45 equals, call it 6.71, equals 6.71. So, alright, units, because they didn't tell us whether it's inches, centimeter, meter, whatever it is. So 6.71. So that's the modulus. The argument is the angle here. Call this angle alpha. Now, you have alpha on the left and you have this side on the right, so it's opposite to it. You also have the 6. So you can say tan of alpha is opposite, which is 3, divided by hypotenuse, which is 6. Alright? So remember, this was for part B. This calculation shows 6.71 units. So the answer is 6.71. Right, that's the answer here. The argument now, part C. The argument is tan inverse of, what was it? 3 over 6. 3 divided by 6, which is tan inverse of a half. What's the tan inverse of a half? I know that 3 divided by 6 is a half, or 0.5, as we're going to use on the calculator here. So the tan inverse of 0.5 equals 26.57. Alright? 26.57. So the argument is 26.57 degrees. Alright? And then here it says expressed in polar form. In polar form, Z would be R cos theta plus J. I use J. Right? Sometimes you say I being used, but if you study electrical engineering, you don't want to mix the I up with intensity of current, so we use J. Plus J sine theta. Alright? Just as a quick reminder, you know that this is theta, this is the J axis, and this is the real axis. So sine theta is the opposite, the J over hypotenuse, sine theta, and this would be R. Oh, R multiplies both of them, so I'll put this in bracket. Sine theta would be opposite, J over hypotenuse, R. Right? So here we have R, oh, not J. If we call this X and this Y, right? Y, sine theta would be Y over R. So Y would be R sine theta, right? And you have the J there to show. Because if you open the brackets, you know, suppose you open the bracket, then R would multiply both of these. So Y would be R sine theta, RJ sine theta, right? Y equal R and J sine theta. And then cos theta, right here, is the adjacent X over the hypotenuse, R. So X would be R cos theta, right? Just in case it slips your memory for a moment, you're doing the maths and or maybe you're in exam, you get a formula sheet though. But if this is not on the formula sheet, then you have to try and remember it. But anyway, Z is R cos theta plus RJ sine theta. So you can factor out the R. So Z equals, R is what again? The modulus is 6.71. So it's 6.71 cos 26.57 plus, and then here, all right, it's a negative 26.57, I should say, right? Plus, so it's going to be 6.71 J sine negative 26.57. Now, why did I say negative 26.57? It's because to measure the angle 26.57, I went this direction, clockwise, is negative direction. Normally, you measure the angle in an anti-clockwise direction. So this would be the same as if you go anti-clockwise, it will be 360 minus the 26.57 degrees, which would be equal to what? Let's draw for our calculator and work that out. So 360 minus equal 333.43. So 333.43. Right? So you could write it as Z equals 6.71 cos 333.43 plus 6.71 J sine 333.43. Now let's check something here. Is the cosine let's check cos negative 26.57. Cosine of negative 26.57 close bracket equal 0.89. What about the cos? The cosine of 333.43. What is it? Same 0.89 you get. Alright? Now what about the sine? The sine of negative 26.57 close bracket equal. You have negative 0.447. Now, what about the sine of 330? Let's clear the calculator first. Yeah. What about the sine of 333.43 equal? You get the same negative 0.447. So it doesn't matter which one you use, right? But you have to remember that if you're measuring the angle clockwise, it's a negative. It goes down this way. But anti-clockwise, you go all the way around 360, then you back up 26.57. Take 26.57 off, and you end up along the same line with the same angle. Alright? Alright, so that's what you have there.